also show MPLS forwarding table. Okay, you can see that for quad 5 we have label 18 for outgoing label. Okay, and we use Ethernet 01 for sending traffic to the quad 5. And you know that the next hop label is the label that is received from the next hop. It's so easy. Show MPLS LDP binding. An interesting command exists for informing to you what is the next hop label. You use show MPLS LDP binding to check, to show the LIB. You can use another useful command, show MPLS IP binding. Show MPLS IP binding and also show MPLS LDP binding, both of them show to you the LIB, but with one interesting more option in the second command. Let's see it. Show MPLS IP binding. You can see with the second command we receive almost the same result, but let's check it. For example, for quad 5 and quad 5, in the first command lib entry quad 5/32, and also in the second command in label, this means local binding label is 200, it's the same, and out label, this means the remote binding. You can see the labels. Okay, and now we have an additional information in use. In use means this label is the next hop label. It's so interesting. What is the in label and out label? You can understand this function when you see the show on MPLS forwarding table. This is the LFIB. You know that in forwarding table we use local label for first field, that is 200, in label. This means that if a packet receives to this router with or incoming to this router with this label 200 in label, we should send this traffic, we should swap the label to 18, and this is the out label in use, next hop label, and send it on the ETH01. Because of that, here we can see in show MPLS IP binding in label 200, this means the local label, and out label 18, this is the next hop label that reside in the MPLS LIB. Okay, don't forget that maybe it's better to use show MPLS IP binding. Also, we can check the LIB or label information base more specifically. For example, in R2, I can use show MPLS LDP binding, okay, only for specific routes, quad 5, quad 255, okay? Or maybe you want to see only local labels, show MPLS LDP binding local labels, okay? Locally assigned value, for example, I want to see a local label as 100 or 200 because it's R2, okay? Only shows me to the subnet with the local label of 200, or maybe between 200 and 299, okay, with a space. It's okay. We can see the local labels for the routes that the local label is between 200 and 299. Or maybe you want to see show MPLS LDP binding for remote label, okay, remote label 18, for example, or remote label 18-21, okay? It shows me all of the labels in this range, okay? And maybe some other useful filtering command. All of these are possible, and you can select that filters and show and give the result more specifically. Okay, this is the LIB. And now we have an extra command for monitoring show MPLS IP binding, and also we can use some of the filters that are available for this command. The next things I want to show you is that a propagation of TTL. You know the process of propagating of a TTL. Let me review it. I want first review the propagation of TTL in MPLS. For example, we have R1 and then R2 and then R3 and then R4. Okay, and a network, for example, net A. And we enabled MPLS between R1 and R2. Okay, here MPLS, and here R2 and R3, and R3 and R4 MPLS. And you know that if, for example, R1 sends a traffic, for example, ICMP echo to the net A, it should use two labels. First, in IP, it should use two TTL value. First, in the IP header, and second, in the MPLS header. In IPTTL, R1 used the default label, for example, 255, and again, it uses the MPLS TTL for MPLS TTL 255 value also, okay? And after that, R1 sends this traffic to R2. The traffic that is received with R2 should be forwarded by LFIB. Why? Because the packet is labeled, you know this. And the packet now, when received in R2, has the IPTTL value of 255, but when R2 forward the traffic, it decreases one number from the MPLS TTL and sends it to R3. And again, R3 should send this traffic to R4, and R3 is the penultimate router and should use PHP. Because of that, R3 first decrease one value from the MPLS TTL, and the MPLS TTL is now 253, and after that remove the label and copy the value of TTL, MPLS TTL, to the IPTTL. And finally, with 253, the packet receives to R4. This is the IPTTL. R4 forward the packet to the net A with IPTTL 252. This is the IP propagation TTL, okay, in MPLS, between MPLS and IPTTL, okay. In the first router that pushes the label, the TTL value of IP copied to the MPLS TTL, and at the penultimate router, TTL value of MPLS copied to the TTL of IP. And maybe you experience a little different scenario. Let's explain it. For example, you don't enable R1 in R1 MPLS. For example, here, look at here, we use IP between R1 and R2. This is an interesting scenario. Let's check it. When R1 sends the traffic to net A, only use IPTTL, and IPTTL is 255. The packet is received with R2, and R2, because that the packet is a IP packet, is an IP packet and not a labeled packet, should check it with FIB. And because of that, IPTTL is decreased with one number, and IPTTL now is 254, and then the IPTTL copied to the MPLS TTL, and MPLS TTL now is 254. And then traffic should send to R3. In R3, traffic is received with MPLS TTL of 254. One number of MPLS TTL now is decreased to 253, and the packet should be popped. Because of that, MPLS TTL removed, and the TTL of 253 copied to the IPTTL. Okay, IPTL now is 253, and after that, the packet is forwarded to the R4. R4 should send with 252. Here also is 252. Okay, it's my mistake. 252, 252. And the result is the same. 255 first from R1 and to MPLS TTL 255. But in the second scenario, we have only unlabeled packet, but the same result. Let's check it first. In R1, for example, now we have MPLS enabled interfaces. Because of that, we can check the links between R1, R2, R3, and R4 and R1.